So when you make a measurement, the number of decimal places that you report is not arbitrary. It's governed by the precision of that instrument. And so here I have some examples of how to make measurements to the correct level of precision. So when you record or report a measurement, the number of decimal places you report is important. It tells other scientists about how precise your measurement is. And the last decimal place that you report is always the one that has some uncertainty. All the other decimal places before that you're sure about, and the last one you report is where the uncertainty is. And so that's understood by all scientists. When we write down a measurement, we all follow the same convention. And so when you look at a number that anybody has written down, you know how precise that measurement is. Right? For example, if you see someone write down a mass of just 24.1 grams, versus someone who recorded the same mass at 24.098235, right? This person probably just used a balance that you might typically find in your kitchen, whereas this one used a very expensive analytical balance. And this result is much more precise. All right, so when you're reading equipment, how do you know what precision you should record it to? How many decimal places should you record? Well, on most balances nowadays, it's pretty easy. However many digits it spits out, that's how many you should record. But when we're reading glassware or rulers, we have to determine how many decimal places we report based on the markings on the glassware or the rulers or whatever piece of equipment we have. And so what you need to do is decide what decimal place do the smallest markings represent on that instrument, and then we record one decimal place past that. And so we have to estimate where the measurement falls in between the actual markings on the instrument. And we know that's an estimate, but everybody looking at that result knows that you've estimated that value. And then anytime you're reading glassware, you want to remember that water tends to crawl up the sides of glassware. And it doesn't create a flat surface, but it creates a curved surface that we call the meniscus. And so when we're reading glassware, we always take our reading and the glassware is calibrated so that we'll get the proper value if we record from the bottom of the meniscus. And so if I was going to read this particular graduated cylinder, the markings are in milliliters, and so these big lines are milliliters. I have 4 milliliters, 5 milliliters, 6 milliliters, and so these smaller lines represent tenths of a milliliter. So because the tenth of a milliliter is marked, I should record one past that. So I should record my value to hundredths of milliliters. And so we can be sure about the ones place and the tenths place, right? We're in between 4 and 5. So if I'm reading that, I have 4. No, let's use a better color. I have 4 point, and then if I'm reading from the bottom of the meniscus, right, I'm definitely in between 4.5 and 4.6, so it's 4.5 something, and I'm sure about the 4.5, right? I have to estimate where it is between the 0.5 and the 0.6, and it looks like it's closer to the 0.6, and so I might call that 4.57 milliliters. So the equipment is marked to the tenths place, and so I have to read it, I have to estimate the last digit in the hundredths place. Alright, here's another example. It's kind of blurry on the left, so we've got it blown up here. This is again in milliliters. And so the big markings here are in tens of milliliters. And so these little markings are in milliliters, so 31, 32, 33, 34, 35, 36, 37. So the ones place is marked, so I have to estimate to the tenths place. So I can be sure about the tens place. I know that's a 3. And then, right, this would be 35, 36, 37. It's in between 36 and 37, so it's 36 point. And then again, this looks like it's probably closer to the 37 than the 36, and so I might call that 36.8 milliliters. Now, if you estimated that last decimal place differently, of course, that's fine, right? The last digit is estimated. So if you said that was 36.7 and I said it was 36.8, neither one of us is wrong, right? There is uncertainty in that last decimal place, and so different people are going to estimate that differently, and that is always true about the last digit that we're going to report. All right, here's another example. And so again, I think the big markings are tens. So I've got 30, and then each of the smaller markings are to the ones place. So 31, 32, 33, 34, 35. Right? And in this case, it looks to me like we're ever so slightly above the 30 line. Right? And so if it was right on the line, it would be 30. If it was right on this line, it would be 31. So I'm sure about the 3. I'm sure about the 0. It's just a little bit past that, and so I might call it 30.1 milliliters. Now, if you said it was right on the line, that could certainly be the case. This picture is a little bit blurry. If that was the case, you would still have to report that last decimal place, and so you would have to call it 30.0 milliliters. Because the ones place is marked, the last digit we report has to be one past that, and so you've got to represent it. If it's right on the line, it would be 30.0. Right, now this doesn't just apply to reading glassware. The other common place where we'll encounter this in our specific lab is using rulers, but the same rules apply. In this case, our units are centimeters, and so the big ones are 11 and 12. Each of the big lines represents 1 centimeter, so the smaller lines represent 1/10 of a centimeter. So we've got to write it to the 100th place, so I can be sure we're in between the 11.6 and 11.7. So I would record it as 11. It's past the 6, in between the 6 and the 7, and I might estimate that as 11.63 centimeters. All right, so when you're taking these measurements, always determine what the smallest markings are on that glassware or ruler or whatever it is, and then you have to estimate one past those smallest markings, and that last decimal place that we report is always estimated.